Hello, we are going to take notes on lesson 25B, part 1 of 1. Okay, so we're going to talk about two pieces of vocabulary, an explicit formula and a recursive formula, before we get on to the examples. So in your vocabulary, it's explicit formula, and at any point you can pause the video and you can write this down. So you have your explicit formula, which is a formula for the sequence. This is your sequence, 8, -16, 32, ... So make sure you write that down at the top too. And it allows you to find the value of any term in the sequence, which means this is the formula that is most used. It's probably the easiest to create too, because it's like, I need to find the 10th term. I'm going to plug in a 10. That's the name of my term, and I'm going to find what this is. This is in the case where if you need to find a certain nth term, you would use the explicit formula. In this case, we should start with, in general, geometric sequences will have a sub n. This is just the name. This notation is just the name, a sub n. I could have named it anything. I could have named it Caleb, but I didn't. I named it a sub n. That's all it is. It does, like this, a sub 10 does not have a value of any. It's just the name of the term, the 10th term. I could have named it Jonathan, but I didn't. I named it a sub 10. So a naught is the initial value. So if this is not given to you, you will have to solve for this in a certain way, which we'll practice in class. But if a sub naught, the initial condition, is not given to you, you will have to solve for it. I said that, but I didn't write that, but you should write that down. A sub n is equal to a naught r to the n power. R is your ratio, your common ratio. And to find that, you just take any number and you divide it by the previous number. Instead of subtracting like you would do with an arithmetic sequence, you're going to divide, because that is the operation we use for geometric sequences. We multiply and we divide. So in this case, our common ratio is 2. This is our common ratio. Then we are going to, n is our input. That means whatever you choose, whether it's the 10th term, you would put n as 10. If it's the 12th term, you put n as 12. So I didn't write that down, but however you want to write that in your note, n is your input. A of n, this whole thing, is your output. When I ask you what is the 10th term of a sequence, you're going to get a number, and that is your output, or this a sub n. If I ask you for the 10th term, it'll be called a sub n. Okay, let's try writing an explicit formula for this sequence here. I'm going to erase everything. Okay, this is not a very long video. We're just going over these two things. An explicit formula. Oh, I should write this. Oh my goodness, what is this? Let me write it again, but with smaller pen. A sub n is equal to a naught r to the n power. In this case, a naught is given, and that's -4, sorry. The ratio, we had calculated it before, but I'll do it again. I'm going to take a number and divide it by the previous number. So my ratio is 2. So this a sub n is equal to -4, -2, n. Can we combine -4 and -2? No, because PEMDAS says you have to deal with the exponents before you deal with multiplication. So this is what our answer is, this guy. This is the explicit formula. But it's great, because if I asked you what a sub 12 is, you could write 12 up here, and then this whole thing would be your output, a sub n. Recursive formula. Let's do this. A recursive formula is more used for coding, or it's more used for, the whole point of it is that you need to call back your previous term. So whatever your previous term is, it's going to help you come up with your new term. A recursive formula for a sequence allows you to find the value of the nth term in the sequence if you know the value of the n minus 1 term. So you have to know what the previous term is. This n minus 1, that just means the previous term. Say, for example, I have my previous term, and this is my current term or my present term. Say in my sequence, my current term is negative 16th. The one before that is 8. So, and this is a sub 1, a sub 2. So if this is, or it's also another name for it is a sub 2, and this is a sub 1. Notice how the current term is always 1 more than the previous term, and the previous term is always 1 less than the current term. So if this is a sub n, then this previous term is a sub n minus 1. But if the previous term was a sub n, the current term would be a to the n plus 1. So you have to think about it. 2 is always going to be 1 more than 1, but 1 is always going to be 1 less than 2. So there's a couple ways to write this. So let's write the recursive formula for this. The recursive formula for this is you have a sub n, and in Engage New York, they actually start with a sub 0. So the lowest number that you can plug in for n is 0. So the previous term is going to be, if we start with 0 and then our next term is 1, our previous term is n, so our current term is n plus 1. And then you just multiply it by the ratio. So whatever your previous term is, you're going to multiply it by the ratio. So a sub n plus 1 equals a to the n times r. In this case, a to the n is, in our problem above, our ratio is negative 2. And then that's going to be our recursive formula. You can also rewrite this as negative 2 a sub n. So if I ask the output for the third term, that means if this is going to be a3, then it has to be 2 plus 1. And this is going to be minus 2 times a sub 2. That's how it's going to work. That's all you need to know for the next video. So write a summary, double check that you have these definitions in your notes, and then move on to part 2. Oh, this is part 1 of 1. Sorry, this is part 1 of 2. You have another video after this. Bye.